record to the floor. Perfect. It has been a while since the last meeting, so I'm especially interested in any updates from Siemens. Thomas, or should we just start there or whatever?
Yeah, we
feel
can.
free to.
I can, of course, I can give some of the updates. As it was announced also on Zulip, Siemens is not anymore a paying member of the White Coat Alliance.
Mm-hmm.
That doesn't mean that there was any sort of interest, that we do not commit to the mission of the White Coat Alliance. But yeah, there were some internal assessments on it, and that was the result that has been communicated. That the direct consequence was that the chair is not anymore with the colleagues of Siemens, so it's not Chris Woods and Dominic Tucker. So they were not able to open up the meetings. So it was not this meeting, and because of the lack of the chair, the meetings did not take place. So thankfully, you, Christoph, stepped in so that we can have that meeting. So this is one point. The other point is that we are still in the evaluation phase, so we are trying to use it in future products.
Mm-hmm.
This is still on the roadmap, and yeah, I would expect to have some more details in just a couple of weeks, but I cannot give you more information on that right now.
Yeah, I'm always interested in updates from new products.
I can give you some things that already have been communicated, and that is that currently in the most relevant areas, it seems that we're not going to use WASI, and we're not going to use the component model. This is also, yeah, it's a maturity question on the one hand side.
No.
On the other side, it's that some things are not designed in the way as we need them to be. This also holds for YCP1 and also for the component model. Not yet. It doesn't mean that it can yeah, go into the direction, and we are happy every time to say, okay, what we need, and then we already did that also regarding the component model. As said, we see the merits in it, but of course there are also other ways, things like decoupling the WASI implementation from runtimes, for example. Decoupling things, so the let's say interweaving or intermingling the dependencies of APIs into runtimes, what that means, what this could be done, things like vendor logins then kick in. Replaceability of things is a thing that is of concern. Then, of course, if you think about WASI-P1, then there is functionality we do not want to be visible to the customer. For example, the way that WASI-P1 is built with the muscle as it is taken. When we took a look into the repository, this led to some insights that we might end up in doing it a bit different, which means that we cannot take it just right out of the box. We also have seen that the realloc is going away from the component model, or is, let's say, treated in a different way, which is to us the right direction. However, the tooling is not in the shape that we can use it in a product directly. And that means that we ended up in saying, okay, we want to use a WAML runtime. So it will be WAML, at least to the current state we are currently in. Yeah, we might lead to wasm time. When we might lead to wasm time at some time. That might be possible in case the devices get stronger, for example. For some use cases, we already use wasm time. For some internal use cases, because of ease of use, for example. This can also tell you. And therefore, it's very, very important that the generated artifacts run semantically equivalent on different runtimes, which basically can only be guaranteed if the system interface is kind of mocked away. And this is one of the impediments. So the question of how a system interface is related to a runtime, which basically should only be a kind of a calculator, so executing code in a sandbox. This is an architectural question that is also on the table for WAML. As you know, there are some security issues upcoming, and there's some discussions in the bytecode alliance, as you might be aware of, which we talk about, and which leads to the question: how should WAML be, architecturally built up in the future? For example, is WASI weaved in? Yes or no? Is a WASI libc weaved in? Yes or no? What about the compile tool chain? What is a security issue when you do an AOT compilation? We have seen some issues in Clang, especially when doing AOT compilation, especially when debug information is on the list. We talked to Derek Scuff, H. Han, and brought up some very minimal examples that showed a quadratic behavior in runtime when compiling some WASM files. They've seen it and fixed it, and we have seen some other quirks that have been fixed from LLVM 18 to LLVM 22. Which means that all of the chain, if you put it in that way, is still kind of a moving target. But it seems that it's stabilizing, and as I can tell you from our use cases, we need very fast compilation times. So I'm talking about very low seconds. I'm talking about hot swapping code. Also when debug information is in place, and I'm talking about AOT compilation. I'm talking about sandboxing. I'm talking about diagnosability. All these things kick in, and we are forced to reduce any more or less couplings or immature toolings from our dependency chain. And that's why we opted for not taking the asset in whatever state it might be. So we are treating a WebAssembly runtime just to be an executing thing currently. If you talk about FFI, this is something we are very well aware of. But currently we are opting for doing it how it is done for the last decades. FFI means C81.
Yep. So basically some header files which describe the API, like it was done in the early times of WASI P1.
Yes, and not only like how you describe it with header files, but also a C API. So what is a string? It's a character array which is zero terminated, for example. The description what a data type is made of. This is basically also like it is done in C. So this is the current state. Because this is something we know that it's working. We know counterparts of it, right? The cons that come with it. This is well known. And because of the uncertainty of what may come next, we cannot take it. That's basically it.
Yeah. So if I guess correctly, the problems with the VASI up to P3 component model is the allocation, which is
Yes,
necessary for
yes,
exchanging more complex data types.
for example, right. And if you take width into account, the question is where comes width from? Who is doing this? And
Yep.
if you take the what our customers need to do, then the question is, do we want to put the burden of writing a width file to our customer? And the answer is clearly no.
Mhm.
So where does it come from? Can it be generated? Can a width file be generated from something? Right? So the other way around, more or less, because what customers know is not width. They know C, maybe they know Rust, maybe they know other languages, right?
Yep.
So what does this mean and who is doing this? And this is also what I can give you. It is totally fair to say if someone, Siemens or any other company, needs something, they should contribute it. And there is an open source manifesto, Siemens, that is encouraging all the business units in doing this. However, I can tell you that this only will be done if the business unit is forced to do it. So if there
Mhm.
is a clear advantage in doing it, and if this is not that clear, it will not be done. This is fair enough. I think it's unrealistic to think about in a different way. Every company is doing this open source that way if it's advantages for that company in doing this, right? Fastly is doing it in that way. Microsoft is doing it in that way because they have a clear commitment and they say, okay, it applies to our business model.
Mhm.
It belongs to our business model. And as long as this is not clear, it will not happen. So, said that, if WebAssembly is in a product, then more contribution will come because then it's a legal matter because of CRA, PLM regulations, some obligations. Um, and then those contributions will come because it's then part of the PLM process. This is what
But
I this is what I
yeah,
also stated directly
yeah.
to some stakeholders.
But
I
you
think this is very, very clear, very
mm,
open, and fair enough.
but you don't have a replacement for the interface definition language at hand. You just use C headers for now. Am I right about this or?
If it will be C headers let's say, as corpses, as format, is
Mhm.
not that clear.
Okay.
But clear is it will be something in that area.
Mhm.
It might be. So, for example, if you think about you are the chief of the compile tool chain, if you are, you don't need headers. You just can use an API of LLVM or whatsoever to describe the FFR. Call it LLVMIR. Or if you use crane lift, call it cliff.
Yep.
Right. So the question is, what is customer visible?
Mhm.
How do
Interesting.
you describe the interoperability of different languages?
Yep.
And there you have different representations on different abstraction levels.
Yep. It's very interesting hearing about your point of view because we operate in a very similar area, but we came to totally different conclusions and are now in a different position because we embraced VASI P3
Mhm.
and are now trying to just embed it in a way or extend it in a way or really work on it in a way that it's ideally doing zero allocations. Of course,
Mhm.
with VASI P3, this is still there's still some road to be taken here, but um, it feels like we can already see that it's possible.
Yeah, I was kind of impressed of your talk at the WASMCon, where you used the idea of describing the FFI, but not using the component model,
Yep.
more or less, right?
Not the WebAssembly component model binary. So just
Right, correctly. The basic idea holds, however, right? And
yep.
that was quite impressive. And yeah, the question stays: what is more or less the engineering surface that your customers are facing?
Yeah,
And I guess here's a very basic difference between your use cases and our use cases.
Sort of, because we also have RXML in the mix.
Yeah, but also from the personas that are interacting with your system, right? If you have embedded users that are used to use C, that do know that the differences for memory allocation, or do know the difficulties for memory management, that are used to use Simulink whatsoever, that are used to cope with embedded devices, right? This is very different to our personas. Our personas are persons who are used to think about automation processes, for example. They are used to put wires in some devices, right? They think very different about a program logic. They think about coils and rungs, right? They do not think about a for loop or a class or an abstraction layer, right? And very heterogeneous personas out there, and you need to be aware of that.
Do you already see a change in the way to do these things due to generative AI?
Yes, of course, drastically.
Okay.
So if there would be a possibility to generate those bindings without having long compile times, without having performance impacts on runtime, yeah, paradise. Go for it. But we are not there yet. So the question is, how does the product roadmap look like? And how does the maturity level fit to this product roadmap? And then design decisions come up.
Ralf, do you have some questions to Thomas? Because I've been talking to Thomas for years now, so I know a lot of the background, but you're new to the ground.
Oh, and hello, I'm sorry. So it's hope it's somehow understandable.
It's good.
Okay, good. Then I have today a good connection. No, I'm still listening. Also, working together with Christoph here, and I think it's a very interesting part about, since I think it's the different kind of users, and as Christoph said, our users are used to IDLs. For them, not having an ADL is actually, and only having a header is the exact opposite. They don't want to have it. They want to have this being generated. Yeah. No,
the basic difference, I think, is that for our users, the IDL is the description of the production process. Right? So
more of an organizational process, or
no? If you think of our production process, you think of this is a press, or this is a drilling machine, or this is right. You are in the automotive space with AutoSAR, right? And you think about how an automobile should look like. Our customers think about how to build an automobile. So what you need to know is, how does the production process look like? What are your equipment modules? What kind of sensor information do you have? What kind of actor information do we have? Where is it located in the production side? How is it interacting with the human-machine interface? How is it interacting with safety? What happens if someone pushes the safety emergency button? So basically, the interface is the interface to the physical world.
Mm-hmm.
And this is something where our customers look at. And this is not done via bit. Not yet.
Well,
it is standardized, kind of. And there are standards
yep.
in this, right? ISA 88, ISA 95.
Yep.
You might know those standards.
So we've been really working towards getting functional safety and WIT together over the past half a or a good more than half a year. And especially if we just reduce the amount of dynamic memory allocations, which are still in there, especially when it comes to asynchronous calls. So because of the complexity of the runtime, which is involved in there. Nevertheless, we feel that we are getting close to really having a functional safety qualifiable implementation. So really something you can audit.
Cool.
You can put into an ECU, for example, a Cortex-M, and it would run with real-time guarantees because it's ahead of time compiled. So of course, this ahead of time compiled is the single trick we need to apply because just in time doesn't make much sense. The car compiling all of the internal software whenever you start the car is not a reasonable way to go. Typically, you do it during updates and then never again until the next update. Also very similar to the phone, which is doing all the pre-compilation steps now whenever you update an app and not when you start an app. And of course, there's functional safety. There is hard real-time constraints. Although I guess you're in a much more constrained, I would say industrial is a bit more strict when it comes to functional safety than automotive. But of course, with this ASIL-D, you come very close to SIL 3, if I'm not mistaken.
Yes. I'm not sure. There are also some, if you think about trains, safety integrated is really, really hard in doing it. So we are up to SIL 3 in our domain, certified until the safety integrated level 3. And we also need to make sure that this is working with WebAssembly in place, of course. With all the other things around it, right? As I said, performance, compile performance, debuggability, diagnosability, hot swapping code, right? This is hard, and I think this is also a very basic difference to your space. I think hot code swapping is not that time critical.
For us, it isn't.
Yes, and for us, it's just a basic differentiator between different vendors of those systems, right? And ease of use, of course, is the next thing. No one wants to train his employees again for another language or for another system, right? They are used to do it for the last 30 years, and it should work the very same way as it did the last 30 years because they know how to work with it, right?
Unless AI changes the whole landscape.
Unless AI changes everything, right? And of course, so basically we must be able, so our products must be able to take use of AI and to enable our customers to use AI to get to their product quicker. So it's a different story. I can give you another standard, the 61131. You might have heard of it. It's for programming logic controllers with different languages and a very specific part of it is the description of a resource and of a station and what this means. So an automation station, more or less. And then you have standards of some vendors, especially in the automotive space, right? They have their own standards of how to describe their plants because they want that it works in very different countries very equally, right?
Yep.
And you must support that for some reason. So if you now take WIT into account, not acceptable. It must be generated. They will not write it.
Yep.
Right? So then the question is, who's providing those tools to generate it? And is it worth it in doing it? Yeah, maybe in future it is. I think, yes, we come to the point, but we are not there yet.
I feel that the additional insulation provided by both the WebAssembly components as well as the shared nothing approach of it, which is really a restriction of your API, but this enables me to figure out if either the caller or the callee is actually making a mistake because they don't share any state. So basically everything across this boundary is serializable and also just debuggable, and you can directly tell whether the caller or the callee actually was providing wrong information or acting wrong. And this is something I really like, especially between Rust and C++, where it's easy to make a mistake on one side, and then you need to figure out whether the mistake is on one side or the other. And this is what I really learn to value about VIT, that and especially the component model, that you can tell due to this shared nothing data types which side is actually doing the error, and it's never unclear.
Yeah, this is something I very much adore. So I like very much. The thing is, it has a price. So if you zoom out, you're basically what you're doing with WIT is you're basically having a layer 7 in ISO-OSI protocol. You have a kind of a layer 7 protocol agreement of how to communicate. And from that point of view, you're serializing and deserializing. And that means you have a performance loss. And
with our shared memory buffers and all these things, I think the performance loss is hardly noticeable. And so there are ways, but they're not yet part of VASI P3. I perfectly agree. We directly bet on actually some future extension for shared memory. I know that Luke is still working on lazy lifting and lowering. So having some basically exchanging IDs of data objects, and then later on reading these data objects. I'm not sure. I think we just need to investigate much more within this space. Although we do have an AI prototype already running on embedded. So really with camera images and everything, which is using this shared memory abstraction. And it works fine. Still, of course, with VASI NN, there is still some copying of the tensors here and there. And this is something I would also like to just replace with shared memory access or some lazy lifting, lowering, whatever. So this is clearly. Yep. There are some things I really would like to just tell you about what exactly happened within the component middle, because I don't know whether you're aware of them, but there's really exciting things going on. So there's a talk by Nick Fitzgerald from the last Plumbers conference. I guess it was somewhere beginning of this year. And he talked about reducing the amount of allocations within WASM time to really getting WASM time into a no standard environment. And this was very interesting to me. Of course, there's more things to be done. And he also mentioned the allocations which are still done in WASI P3 in the streaming thing. So this is just another effort to get this towards basically arena allocations, pre-allocated buffers and similar things.
Mhm.
And we are also actively working on there. I'm just in the process of upstreaming one of the patches to Bitbeinchen to get arena allocated resources, which was one of the things which really bothered us, that this was still using boxes. Because in C++ we had already solved it, but in Rust there was no way of doing that yet. But so there's and if you just look for quite recent merge request, you will find it. And of course, the cooperative threads, which just had been described last year, and then during winter time, Alex, Sai, and me just worked on that one to get that into the Vasi SDK. And I think last week, the very important patch to LLVM got merged. So now the cooperative threading support is becoming more real because it's now also part of the LLVM. You need, well, of course, that's I guess threading and WebAssembly is one of the longest stories ever.
Yes, it is.
And so because globals are, if you do not wait for shared everything threads, are not defined whether they are shared or non-shared. So with Vasi threads, Vasi P1 threads, it was basically agreed that they have to be shared, which created an incompatibility with the browser. So these programs cannot be ported to the browser because the browser operates different. And so basically they found, okay, we cannot use globals. We have to use a different way. So they introduced I always call them intrinsics, but they have a different name. So something within which resembles a function call, but can compile to something different, which gives you access to thread local storage and a thread local stack pointer. So the linear stack in the linear memory, which is doing all the values you pass by reference. And these two things, of course, need to be supported by the compiler. And this leads to another binary incompatible variant of WebAssembly, which I found very tragic, but nevertheless, there was no way around that. And this is now becoming reality. And so there's a good chance that within this fall, there will be an SDK which you can just use to compile programs, random C-based programs using pthreads and sockets to WebAssembly, to basically Vasi P3.1 something. And they will just work because they are emulating the pthreads using cooperative threading.
Okay.
And this is very exciting, but of course that's, yeah, a lot of work has already been done, but I guess there's also still more things to do, especially because now, after waiting for the LLVM patch for some months, everything has become unblocked again, and now the SDK could basically start shipping this threads. And that, of course, is deeply ingrained with Vasi P3 and the component model. But I'm super excited that just to see that becoming reality, because then you can just take a random C or C++ program, especially if it's doing some network interaction. It will for sure use pthreads. And being able to just run that on a single-threaded runtime is very interesting. And sorry, the name currently eludes me, but another person is working on the debugger adapters. And they split it into two parts. And one part is the lower part, which is, of course, runtime dependent. And that one is implemented in runtime. Basically, it's the functionality you expect from a JTAG adapter. So setting breakpoints, inspecting memory, and continuing. And then the upper part is just a WebAssembly component, which you just load into your runtime, and that one then provides either DAP or LLDB or GDB server access. So basically does all the interaction with the underlying hardware drivers and the basically the debugger protocol on your other side. And I have some hope of just integrating that in our embedded devices and being able to just debug at source code level our embedded devices from afar. Yeah, is one of the dreams I clearly have.
Yeah, sounds very interesting.
Yeah.
On the debugger side, there are also, so from our perspective, very different use cases. From the one hand side, you have the use cases, as you already mentioned, via breakpoints. You can imagine stopping a machine is not acceptable. So it's like you're driving your car with 180 kilometers an hour, and then you put in the rear gear into it. Not wanted at all, right? So having breakpoints on a running machine is not acceptable. However, there are use cases where you need to step through it. So where you need a kind of a breakpoint. The question is, what do you do with the use cases where you do not have the possibility to break the code? So to stop execution. You want to diagnose it, however, right? And that does not mean you have to break it, so to stop it. That does mean you have to observe it. Now the question is, how do I get the state that I want to observe without having a big impact on the real-time behavior? So having jitters. Runtime jitters.
Typically, you just bolt another hardware close to your CPU and just.
But if you don't have another hardware in place, what do you do then? Yeah. So, and this is also the question that we need to take into account because our customers have this need.
I can perfectly understand.
Right. So, yes, we need the adapter protocol. We need those things, but we also need a different approach. And this is where does this come from? So, and currently, this is a very specific requirement in our domain, and I'm pretty sure that this will not be solved via WebAssembly or any kind of standardization facility. This is usually something that is vendor specific. And if it's vendor specific, then it's part of a system interface. And then is the question, okay, what does it mean? How does it have an impact on the compile tool chain? How does it have impact on describing the system interface? Yeah, this is something that we need to take care about and we must have a look at. So, however, as said, we're having a debug adapter protocol, having a better debuggability is a very high value. But it's not done online, as we call it. It's not done on the device itself. It's only done on the device if the device is not directly connected to a PhysIC. It's then connected to a simulating system or to a mock or to something where nothing can go wrong. Where you can simulate how does the gearbox react if I put the rear gear into if I'm moving forward with 180 kilometers an hour.
Yeah.
Will it explode?
No one wants to sit in the car when it's happening.
Correctly.
Yeah. And there's, of course, I don't know whether you've already heard that we created a way of just creating VASI, so classical VASI modules from components by just fusing them together. Of course, you need multi-memory because otherwise there's no way of just doing these things because
Yeah.
The only other option is if you have compiled your part of the program in a specific binary format, which is tailored towards shared libraries for, so position independent code, I think is the proper compiler flag, which just does not put every part of, so basically it still has some flexibility at load time instead of fixing everything at link time. But this is, yeah. So one of the things which is part of the Pulse engine .eu
Yeah, I heard about
ecosystem.
it.
Yeah. And this it's called Melt, and this basically just fuses, or I like to call it sintering of components into then a normal classical WebAssembly module.
Okay.
Which can of course enable VMware to just run components if you add this additional step in between. But then of course you still have probably some interfaces, and given my experience with VASI P3 and all the benefits this asynchronous resyncing of all the system interfaces, this really, so basically this IO Uring, like I'm not sure whether that's 100% true, or I know that there's completion based and other ways of doing asynchronous things. So I don't know whether it's 100% match, but nevertheless having an asynchronous WebAssembly system interface, so VASI 0.3, it just feels so much more modern than anything before. On the other hand, yeah, I guess it's 2 days until the vote is hopefully just to pass for VASI P3 and everything gets fully announced. It's scheduled for this Thursday. Or is it today? Is it tomorrow? I don't know whether it's the 10th or 11th. So actually it's scheduled for this week. And at least during the past 3 to 4 months, nothing surprising came up which would endanger this release.
It sounds promising.
Yeah. And having used it now for really a good year, I cannot imagine going back because of all these nice asynchronous interfaces. You just ask for things and you get a notification back whenever it's happened, and you can do many things in parallel, and it's not blocking. Yeah, basically you just put all of the execution control back into the runtime, and it's no longer has to be duplicated within the component itself. And this feels so good. Yeah. Still, there's some things to fix there, but nevertheless, this is yeah. I really enjoy working with VASI P3, even though it still has its yeah, memory allocations and similar things, which you need to figure out how to get around.
Yeah, sounds good.
Yeah. So exciting times, especially with all the acceleration of coding done by AI support. Yeah.
Yeah,
it has changed the landscape of software development dramatically.
Yeah, and it will continue on doing it. Yeah, I use it also more or less in my daily work. However, I do it in an iterative way.
Mhm.
It's also no trust at first sight.
Yeah, I know that Ralph is doing a lot of, I would call it professional level AI code generation, and his work on just doing proofs using formal languages of the correctness of the code which is generated by AI. And even the proofs are generated by AI because it can just do. This is quite exciting to see these things.
The question is it a self-feeding system, right?
It's always better to take a closer look, and it's better, better control or check than actually being sorry.
Yeah, I think all of the friction points you have in normal development, do my safety levels of my supplier are the right, whatever they implemented. In the end, everything what is a friction point there also will be a friction point with the AI. I think maybe this is also one of the parts. What I see is, I think it's when I'm now working on this. For me, it was you work at the Indra or maybe some of the other universities, formal languages. Now seeing this AI can do this for me, and it actually can do this now in a way where I can do at least the proofs together with it, have the unit tests, all the other parts with it. It gives some parts which it can do some work on it. Of course, you need to check on this, but it's the learning about the different languages. Maybe this comes then in. Once you really use it, it really doesn't really matter too much anymore if it's today. Now what I think I have 3 or 4 different formal proof languages I've now experienced. So, and usually in the lifetime of a human, that's 1 maximum. Yeah. And I think it also comes now in. It's like also I had it in a complete different part. All my Yocto knowledge I had in my past. Now, when utilizing this with the AI, it basically outsmarts me their way in parts which I have not even thought about. But for sure, it's always the question when utilizing this is the part of, let's say, since everything is based on language and for humans, for the AI, there is some kind of let's say, how would I say, it's a rubber floor where you have to walk on and have to say, so which part do I have to look into to actually acknowledge this and which I have to prove differently. And I think usually the way when going into this is by overlapping certain enforcements. I can prove it because it runs, for example, directly in hardware. By this I know. It has its way. It also has other parts about this proof. So, but it's I think it's just the way of how now with AI it's more of we have to learn because it's more like outsourcing it to some external supplier and then trusting basically back in the way and putting the gates in of how you want to create your, let's say, your proof points of whatever you get delivered is okay, or if also the AI just use Stack Overflow or Reddit to copy things in, which might seem right, but are not.
Yeah, I agree.
So I have a meeting in 5 minutes from now, which I need to go to. Thomas, thanks a lot for the chat. It was very interesting, and yeah, I definitely plan to keep it up. So
Great.
So 2 weeks from now, I don't know whether it's the US and Europe or the Asia and US. That is, of course, something which I would need to figure out who can lead that, because that's during my night sleeping time. Nevertheless, I enjoyed every minute of today and got so much interesting things to think about, and yeah, some nice perspective into what's currently all going on within the industry with WebAssembly. So thanks for that.
Yeah, thank you for keeping it up. And yeah, let's see yeah, whether the interest will increase again. So,
I'm quite sure that there's more people interested. It was just on very short notice.
yeah, and as said, the last meetings just were cancelled without any message.
Yep.
Due to the lack of a chair. Okay, Christoph, thank you. And yeah, if there is the need to reschedule some meetings, just go ahead.
I will just let you know via Zulip, so it's easy to communicate there.
Thank you a lot. Thanks a lot.
Thanks a lot. Thank also Ralph, and yeah, see you next time.
Yeah. Have a nice day.
Thank
Bye.
you. Have a nice day.